Hello, everybody. I believe this should be live now, which means we get to talk about today's topic. So, as I mentioned on Twitter, the plan had been that we were going to take a look at some shellcoding stuff. Something that I've wanted to play with a little bit more for a while. Like, we've got some time here. Let's take a look at some shellcoding, write some interesting shellcode, something that's very unique. However, so I should be live now. Hopefully this is live, otherwise everything is broken. I'm hoping I did not forget how to do this in the long amount of time since the last of these. Sorry. So, what I was saying, I can't type on both keyboards like this. The plan had originally been that we were going to take a look at shellcoding. But, as you may or may not have seen, over the weekend there was a little bit of discussion about a piece of processor errata. So, let's pull that up here real quick. So, as you may or may not know, Intel, and I think AMD does too, they regularly publish, Intel at least publishes this document, which is all of the many things about their processors that don't quite act the way that they're supposed to, or at least the way they were intended to. And for the most part, these are things you can very solidly consider bugs, like a performance value is reset to FF. Okay, that's a thing. I'm not quite sure why that matters, but because I don't actually know what that value does. Oh, wow, I did not change these. Sorry. Yeah, let me get this fixed real quick. So our current status is we are doing SKL150 analysis. And in a second here, we'll get to what exactly the SKL150 is. And our next stream is going to be the 28th. Okay, thank you for reminding me about that. Right, so, where are we here? The one that's interesting, the one that came up here, and that I saw a few different people talking about on Twitter, is this one right here. It's SKL150. Short loops which use AH, BH, CH, DH registers may cause unpredictable system behavior. That's such a great sounding description. So basically, as far as I've seen so far, I have not seen very solid technical details. So my hope for this evening is that we're going to take a look at this. I am currently getting a second machine set up. It took a little bit longer to pull down a useful ISO than I had hoped for, but we're getting close. And once it's ready, it has a Skylake processor in it, so we should be able to reproduce this, and hopefully we can figure out exactly what's going on. Because the important wording here, and the one that I would definitely like to know way more about, is what exactly this unpredictable system behavior is. Because, I don't know, if there's chunks of code that when executed will cause a full system crash, that's bad. It's definitely interesting. It's something I'd like to know more about. But more interesting is, what if it's a little more controllable? If we take a look at the description we have here, if a loop of less than 64 instructions uses one of these 4 registers, so those are, what am I going here for? I want Intel x86. And do we have registers in here? Wikipedia had a really good x86 64 registers. I know I've seen some really good diagrams of this. Sure, let's take a look at this one. So basically, for each of these registers, we have AL and AH, which make up the lowest 8 bits, the second 8 bits. Then you have EAX, which makes up the 32-bit value. And then you'd have RAX, which makes up this whole thing. So basically, there's a number of different registers that you would use to refer to the same actual register. It's just different slices in it. So if we go back over here, basically if we use that second one, so the second 8 bits in the register, as well as a corresponding wider register, so RAX, EAX, or AX, there's some sort of unpredictable behavior, but only when both logical processors are active. So basically, there are certain types of loops that, if hyperthreading is on and you're doing things on both threads, something could happen. In terms of a bug, that sounds wonderful. Unfortunately, this machine is still getting built, the one that we can actually test this on. So we're going to do a little bit more research while we're waiting on this. One thing that I found, so I dug around a little bit today is Monday. So over the past weekend, I was up at SummerCon and didn't do anything useful except for talk to people, and did not get to research this, but I did see it come up. So, one thing I did come across was that the SKL 150, and of course you're not actually going to get to see all of this. So this right here, that's the wrong thing. Oh no, go back to where you were. I want the display capture, there we go. So, this is the actual post on the Debian mailing list that I came across on Twitter. I don't remember who it was that tweeted about it, but I definitely retweeted it as soon as I saw it, because processor bugs are the best. So in this article, it pulls out the same type of description. I think they actually quote in here. One thing that's a little unfortunate is that if you remember a couple months ago, I switched, I guess it was only a month ago, I switched from the machine I had been using to do all these streams to a new machine. Well, an old machine, but a desktop as opposed to a laptop I had been streaming from. And the upside is that laptop has much more screen real estate. I can see so much more. I can, keep track of the chat and everything much more easily while I'm working. The downside is it's a slightly older processor, and it's not a Skylake. I have a Haswell processor in my desktop, but the laptop is a Skylake, which means it is in this list of vulnerable processors. So hopefully, once this thing gets built, we'll be able to connect into it and see if it works. Now, if you haven't read this, there's a lot of text here. I will say, what should I do if I have such processors? Personally, my answer is be super excited, because you get to go play with a processor bug, which isn't something that comes up very often, especially ones that cause interesting effects. So if this is something that causes an interesting effect, I definitely want to be able to play with it. And having a machine that we can play with it on is that much better. So, but the reason we came over to this is because there was a, this little bit right here. So the story here, as they're telling it, is basically that, actually, you know what? I will zoom in because there's no reason for this text to be so small in the video. Back in May, there's a OCaml developer who brings up this issue for Debian to try and fix it. Because back at the beginning of the year, there were some reports of malfunctioning going on that they managed to narrow down to Skylake with hyperthreading enabled. Okay, that's interesting. And then several months later, turns out that Intel releases a microcode update that seems to fix this. So, turns out there was a bug. The OCaml developers saw it, interacted with it, didn't have a good solution, and Intel kind of quietly fixed it. So I believe right here we have the same text we were reading before. You use one of these registers, one of these small parts of the register, and the big part of the register. Something weird happens. Now, one thing I haven't read yet is this, and I think this is what I want. So this right here is the bug report for the OCaml code, I believe, which triggers this. So, as I kind of said, I actually don't know much more about this bug. I don't know much more about this bug than anybody else watching this. In fact, there's a decent chance some of you might have already looked at this and know more than me. So we're kind of going with this to see where we end up. So where are we here? So I hope you don't mind. I'm going to read this out because I have yet to read this bug report. So while switching a 4023 codebase to 403, we stumbled upon some random crashes from the compiler and more rarely occurrences of bad assembly code being generated, which failed to compile, or instruction being trapped at runtime while the compiler is running. Those problems occur on an OCaml source file generated using the extprot library. This doesn't seem to happen all the time. Most of the time, the file will compile successfully, and if enough retries are given, the compiler will then crash. Example of returns from dmessage include, we've got some seg faults here. So I believe the syntax here is we have a seg fault. This is the address that was being accessed. This was the IP that was being used. We have a stack pointer, so IP being RIP because it's a 64-bit system. We have an access of a very low address at a slightly different PC. Another low address, a high address. All of these are different addresses. Backtraces don't seem to be useful. The compiler will more rarely generate an assembly file that it won't be able to compile. Problem doesn't seem to happen all the time. At least it doesn't crash at every build. We sometimes don't witness the crash before 30 minutes of retries. Oh, that's unfortunate. But supposedly we should be able to compile this thing and eventually see a crash. Well, that seems interesting. Even more interesting, my install just finished, so we're going to take a moment here. It's going to be a little bit boring while I hopefully get this system all the way up and running for us to use, to actually show on camera. Because like I said, unfortunately, we're going back to the old machine, which is no longer set up to do the streaming. So, I want you to keep booting, not try and reinstall again. But that means we can't easily show these tests running. When we have the, what's the word I'm looking for here? When we, oh, that pulled up the wrong place. I want a US keyboard layout. Well, this doesn't look good at all. Nope, I totally broke my install on here and did not actually install Ubuntu like I thought I did. So it looks like we're going to take at least a few more minutes to get this whole thing set up again, which is unfortunate. Sorry for the delays. But hopefully we're getting pretty close here. Because once this thing is up and running, my hope at least is that it should be pretty straightforward for us to reproduce this. Because given what we've seen here, so they tell us that they run this in a loop, specifically that it's going to be a threaded loop. I have no idea what these other arguments mean, except that they're compiling some specific stuff. They will cause a crash. And if we come back over here to the description of it, we know that according to Intel, the way to trigger this is to create a loop, use H and RAX. Now, I don't know exactly what we're going to do with that, but I think it should be sufficient for us to at least write some assembly and get working on that. You know, once we have a machine that actually works. I want to install again because you did not install properly. I'm going to blow away everything on the hard drive. Oh, do I want to do that? Sure, I'll do that. What's the worst that happens? What we're hoping for here is that this is all going to work. It's going to be amazing. At least that's kind of the thought. There you hear those nice Ubuntu sounds. Sure, we will connect to the internets for you. So again, sorry that this part is a little bit boring. Since I'm working on this, has anybody actually already looked at this? Because if there is somebody in the chat, it looks like we have at least a few people here. If anybody has already looked at this, I would love to hear a little bit of early research into it, if you've done that. But I suspect, so I've seen basically zero technical data about this. I've seen this right here, this description about the bug, and I have now read through some of this OCaml stuff. But basically nothing else. I haven't seen anybody discussing what it is, good triggers for it, or things like that. So we'll see. Ooh, that's interesting. I didn't think about it, but it makes a lot of sense that MacBooks are going to be affected by this too. That's probably the easiest way to get a hold of it. Yeah, we're just going to blow everything away on this machine. It's unfortunate, because I think there's a little bit of stuff on here I'd kind of like to keep, but we're getting rid of it. Oh. I guess that explains why it did not work out the way that I intended it to. This is what I get for having multiple disks in a machine. I have one of those, you know, a 100-ish gig SSD and then a terabyte of storage on top of that, which is great for most stuff you want to do. I want to do. The downside is that it looks like I installed on the wrong disk the first time around, and it all completely died. Oops. What? So one thing I'm definitely hoping for here is that this isn't somehow OCaml specific. That's going to be quite unfortunate. So I have a Skylake machine, and as soon as I get all of this set up, my hope is that I'm going to be able to SSH into it, and it will just work. That's the hope, at least. One other thing that we're going to have to see about, and that I'm actually really curious about, is, and let's actually go take a look real quick. So what am I doing here? Now, let's, do I have this set up to, no, there's nothing here yet. So if I want EC2 proc info. So this is not recent. I don't actually know off the top of my head. Oh, that's not what I want at all. Tools, that's what I want. Past week. Past month. Sure. Ooh, what is this? I've never seen this before. So what I'm trying to figure out here is if I pull up a EC2 instance right now, what does cat proc info tell us? Which I think all of my keys are not super readily accessible. In fact, I think I actually just blew away some private keys. Oops. Let us pause this one. We are currently here. Connect. Do-do-do-do. Come on. Where is it? There you are. Come on. So I think as soon as we get all of this up and running, we're going to start writing some code real quick. Hopefully that is almost the point we're at here. But yeah, terminal. SSH 134. That is not my username. That is my username. Ah, there we go. So I can close you. We will get rid of you. Okay. So, actually show you what I'm doing, shouldn't I? We have SSH'd into the VM. Do you have anything set up? You do not have anything set up. proc/CPU info. So yeah, unfortunately, the machine I'm streaming on right now is a Haswell processor, which, while it gives me many, many cores, it is old and doesn't have the exciting bugs in it. I think we're all a little bit sad about that. Oh, there we go. So supposedly the installation has finished. Let's see if we can reboot and actually connect to this thing. But while we are waiting for that, projects, we're going to make a new project, which is, what do I want to call this thing? SKL 150. We'll just call it that. Come on. So now I'm going to have to be awful and look up how to do actual threading code because I never remember how to use pthread properly. Like, every single time I want to use... Ooh, there we go. That booted up reasonably well. Every single time that I want to write a multi-threaded application, I have to go on Stack Overflow and get Stack Overflow to tell me how to actually set up multiple threads. Fortunately, we're also going to have to look up how to do inline assembly because that is also in the list of things that I probably will literally never be able to remember how to do properly. Every single time, like between having to use AT&T syntax and the right specifics, it's much easier to look up than have to try and use. But I have this. I need to apt get install open SSH server. Sorry you can't see this. Hopefully, we're about a minute away from being able to have you actually see what I'm doing. Okay, so that is a real IP address on my local network. So I believe I will hopefully be able to come in here and go 019. That is good. So this should be a machine that is vulnerable. Proc CPU info. Because we have a i7 6700 HQ, which if we come back over here, I want a i7-6700 HQ. That is, according to ARC, a Skylake processor, which is what we want to see here. Because that means it should be vulnerable to this. Because it also has... let's move this over so you can actually read the same thing. So it has hyperthreading, because it has twice as many threads as cores. And it is Skylake, which means it should be what we're looking for. I believe it's also... if we come through here, they had a list here, right? I want things formerly called a Skylake, and it's on this list. So we're good. Hello, Lucas, and anybody else who's joined recently. So, where were we? I was going to look up, so this is currently a completely blank machine. We're going to make the projects folder, as we usually do. We want an SKL150. Oh, make dir SKL150 because it seems like a good name. Ooh, I don't think I have... I'm gonna get the real Vim installed. Yes, we'll take the real Vim because Ubuntu only ships with VI and not Vim. I don't usually use any of the things that matters, but it's still nice to have. Okay, so we have that. So I should be able to come in here, go prot. Are you guys? Oh, my sound playing out on the wrong speakers again? My sound is playing out on the wrong speakers again. I want that one. There we go. I was wondering why that didn't quite sound right. One of the downsides to how everything is set up here is I have monitors that are connected by HDMI, so they will occasionally steal my sound output. Or are we? I want a SKL150 folder. So, test.c, and now I need to look up how on earth do I write libpthread code? Yes, I want examples because I'm going to just take this. So we're going to grab this right here. We have code. And I forgot to... there we go. Oh. Resize 80. Oh, look at that. Everything even lines up now. So we are trying to reproduce SQL 150. That is some text for anybody who... Oh, that's unfortunate. I don't have the shortcut set up on this machine. So we have this. We'll create a new window here. What was I doing? I want to gcc -lp thread test.c. Seriously? Did I copy and paste code from the internet that didn't work? No, it did work. I'm a moron and I hit Control A. Yep. That is the downside to using both screen and... But I gave you it. gcc-lp thread. Okay. I don't understand how threads work at all, do I? Oh, they're both looping. Okay, that makes sense. Yes, I have two threads. They're both infinitely looping. We have stuff that happens. Awesome. Except I have... So I have... what is this? 8. I have 8 of these, so I want 8 threads, not 2 threads. Because ideally what we're going to have here, right, is we want to have... If I have code running on all 8 threads, or all 8 possible threads, then I should hit whatever it is I can hit. Right? Sounds like it should work. So if we do this, I'm trying to think of the best way to show this now. Let me get all of this set up real quick. And because I don't think I quite have it configured. I need to walk all the way back out, don't I? Okay. Let's run you. And see if I remember how to do this. Bash SSH into... Sorry, I am attempting to see if I have what is going to be the easiest way to do this? So I could always just pull everything back all the way over here to disassemble it, which is a little bit painful, but I guess it would work fine. That might be the easiest way to do things, now that I think about it, rather than trying to SSH tunnel through all of this, especially since I'm not entirely sure if I have it working. No, you know what? That works fine. I can... If that works, so we want to do Control-A-D, exit... Because I can do SSH forwarding through multiple machines, right? That should work fine. Then we said this was SSH-X 192.168.0.19. That looks like it worked. Ooh. And you can't see it, but I do in fact have Xcalc running here. It looks good. The only other thing I need to do is I need to come in here. And I'm going to grab my Binary Ninja, my copy of Binary Ninja. I will set it up on that machine real quick. And we should be able to then actually disassemble the stuff that we're looking at too. Not just, if that email exists, a license will be sent shortly. I want the Linux I want the Linux download. CD downloads. You know what? I'm going to do this in a different console because I don't actually know how much goes into my link and how unique it is. So, 2.168.0.19. And I want to CD downloads wget. Yeah, I probably don't want that. 403 forbidden. Oh, I forgot. Firefox really doesn't like to be run over X forwarding. I always forget about that. Come on. I only need you to work once. Come on. Hello, Jafra. Your license file is attached. Oh. I also didn't download my license. I should do that. Exactly is a license file. I have a license.txt. Okay. I want to then... It's going uncomfortably slow. We're almost done. Yep. That's all done. Don't care. Oops, I need to reopen that. Sorry this is all taking so long. I ideally would already have all this set up, but you know, there's something to be said for doing it live. Okay, so I now have all this set up. I want to unzip this. It is unzipping nicely. And if I come in here and I do a Binary Ninja, I want to locate my file. And you are relatively happy. It's not super performant, but it works well enough. So we did that, and if we come back over here, Ow. That's unfortunate. We got this working. Forgot to screen dash R. This is where we want it to be. Okay, we want to resize this to 80. We want to resize this one to 80. Want that to be 0, and you to be 1. Look, we're back to something that actually makes sense. And we would also like to open another one of these. Downloads, Binary Ninja. Yeah. Okay, I can live with that. Because you are still SSH'd in. Whoop. That looks good. So where were we? So we have created this, and if we come over here, I want to actually open you up. SKL 150. Oh, I want the project's SKL 150. Apparently I created one in the home directory too. This looks good. We have a main we call pthread create with 2 different threads. So this should be thread 1, I think. Yep. And then we should also have a thread 2. That looks just fine. So what we want to do here is ideally we're going to write a little bit of code now, which instead of printing out hello is going to I'm missing a word here. Sorry. Instead of printing out hello is going to trigger the bug that we're actually looking for. So if we come back over here, let's see. Oh, that's not what I wanted. How lucky am I? So if I have an int a, and I do, it is kind of convenient that this is already in a loop for me. While 1, why are you not set auto indent? While 1, we want to loop through here, and every time we loop through here, I want to do printf %x /n or dash %x. And I want to do a and ox ff00 and a, yeah, that looks good. And we want to do a plus. So this should actually change every time. So hopefully, jeez, I keep doing that. So if you're following along there, you may have seen I keep saving off a hard copy. I remapped the Control A, H, J, K, and L to move around Windows and screen. It's pretty convenient, but it does mean when I don't have them anymore, it gets a little bit annoying. So we have a.out right here. Oh, we should actually recompile this too, shouldn't we? Test.c-pthread. That looks pretty good. We are counting up like we expect to do. That looks good indeed. So if we come over here, now the real trick here, did we get lucky enough that this is just going to work? So what are we doing here? So we call printf. We've loaded 1 register. We've loaded a second register. Okay, so we weren't quite that lucky. What I was hoping for here was that we could just write a couple lines of C here and that would just work. But it didn't quite work that way. How about dash O3? That's all the O's, right? O3 is all the O's. So we open this thing up again. Close. Reopen. Go into main. We're going to look at our first thread. We're still using this. I was really hoping that by turning on optimizations, that would emit the AH that we wanted. Let's think about this for a second. Not quite sure of a better way to do that than... Like, I don't know what else I could do that would get GCC to output an AH instruction. What if I did... Because O3 is going to be the most optimized. What if instead of doing that, we did shift that over by 8, and then we AND it. See, I'm going to keep doing that all night, aren't I? Close it, reopen it, and... Do I understand how compiler optimizations work at all? I do not understand how compiler optimizations work at all. And apparently I'm not lucky enough to have it actually just work. Did I save it? So they're willing to optimize the code I wrote before, but not quite what I wanted. I can live with that. Wait a minute. Am I being dumb here? I think I'm being dumb here. Yeah, I'm being dumb here. I'm using, like, I'm literally using Binary Ninja here. You know what I can do? Instead of having code that does it, I can just patch this. I want to assemble, and I want to do a... What do I actually want to do here? Move EAX AH. Is that a real thing? Invalid size. Because I want to move SW? No, it's an SB. Not a move SB. Okay, Intel x86. I want the manual for this. I can never quite, am I trying to avoid editing it by hand? Yeah, so ideally I want some C code that will trigger this bug, because if I have, here is, you know, a 10-line C program that if you compile it, you will get a crash if you are vulnerable. That's something I can hand out to people. Like, I can go post that on my GitHub right now, and anybody can run this and say, look, I have the crash. Whereas if I have something that I have to hand modify, it'll work, but it won't quite do what I want. Yeah. Like, I would much rather have this just work. But I want a move with sign extension. Oh, it's move SX? Is that what I want? No, I want a... I don't want an SX because that's R16, and I want an R8. Right? I'm pretty sure I want a move. A move SD is a move or merge scalar double precision. I don't think that's what I want. I do. Okay. I'm pretty sure I want to move, right? I want a move. I can never remember which of these is the right one. I want to move, because I want to move AH into EAX and promote, like I want with signed extension. But apparently a move S, yes, I want to move SB. No, I don't. A move SB is not what I think it is it? Oh, yeah, move SB is not what I thought it was at all. So move SB is an address to an address. Yeah, that's me being dumb. I want a... I just want to use... You know what? I will do this. This is not quite what I wanted to do, but I think it should work well enough. Which is I can do a move A-L-A-H. That's a real instruction. Symbol. What on earth are you trying to do here? Undo? So I want options, show addresses. We're going to patch this again. Oh wow, I lost many bytes there. So undo that. Instead of anding, we're going to nop this out real quick. Nop, 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 nop. And we're going to then patch it, because that way we actually get the right number of instructions. There we go. And now we want to save this as a.patched. We come back over here. I should be able to... Oh, I need to chmod plus x a dot plus x a dot patched. Now, it helps if I could type. I said plus x. I apparently typed plus a. So this is definitely doing the thing that they said we should be doing. Like, we are touching both the AH and we're using both AH and EAX. So I would expect this to do something unexpected, right? But we're not doing anything unexpected, are we? Why are we not doing anything particularly unexpected here? Oh, that's why we're not doing anything unexpected. Because this loop, this is me being dumb, sorry. We're going to go back to this. Why are we not doing anything unexpected? Because we're calling printf, which is many, many, many more than a 64 instructions. So that is saved. No, I want to file, save. Okay, maybe this just works. They're still not crashing. At least now I actually believe that we're the right number of instructions. Sorry, I forgot to show you that we're not crashing. We're getting this nice flying cursor effect, but that's just screen not quite keeping up. Move ZX. So I don't, at least according to the move with 0 extend. Yes, the problem is we want AH, not I'm blanking again on this. We want move AH, not AX. Because AH is an 8-bit register, whereas AX is the 16-bit register that is both AH and AL. You know what? Here, let's do this. I'm going to look for R8. Yes, I want an actual instruction that accepts R8. What is a... How regexy can I be here? R8. So we have the move that I'm using. We have a move that we're using. Right, because this is not going to let me do regexes, is it? Of course it's not. So I'm not thrilled that we're not triggering anything. So I have my guesses of what this bug actually is, right? Here, we can all watch my terminal fly by as we talk about this. So my guess here is that for some reason, somebody put in an optimization that if you use these specific registers, so AH as one of them, we were going to be more efficient and do pipelining magic to make it a little bit more efficient. And the catch being there that whatever optimization that was doing that pipelining didn't bother to check what thread we're in. Yeah, you know what? That's an easy fix. Let's fix that real quick because worst case that does nothing. Best case we suddenly just have it working. So I want to delete that and put it there. And I want to do a p thread t2. Right, so QQ yank for yank 1 2 3. Put it. Control A. We're in screen. Wrap. We're in screen. Put. So percent S23G, S24G, 25G, visual 26G. 7G. So the way I would normally do this is actually using a macro for it, because you can do some pretty sweet stuff with Vim macros. Basically, you're able to that one. Thread 8 undeclared. Oh, right. So I don't want them all to be replaced. Oh, I should have just done one. That's unfortunate. If I didn't pass in the G flag, this would have just worked. For shame. What I was saying was that usually I would do this with a Vim macro, but unfortunately the increment, the Control A increment, is, well, actually, kind of curious. If we don't do anything, I just want to test this. Oddly slow like that. I suppose I have like SSH running too, right? So, well, that does a thing. And if we come back over here, we need to reopen this. We've recompiled you. We're in main. Well, this doesn't look right at all. Why don't you look right? If I just recompiled you, open, a.out, pthread create, pthread create, pthread join, pthread join. rm a.out, compile it again, close this, reload this. Oh, I'm a moron, aren't I? Oh no! Oh no, 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 no. I wanted O3, a capital O3. I have been compiling that to a file called 3. Okay. Sorry, guys. So this uses BH and BX. Turns out, that just works, apparently. But that's not quite what we wanted. Okay, so when we turned on when we turned on the optimizations, we got what we wanted. Go away for a second. I want to do this. But we want to get rid of the printf, right? So we want to do a is equal to, what did we have here? That, right? So hopefully this ends up not just dying on us. I feel really dumb now that I was using a lowercase o and saying, why aren't you changing properly? When you're compiling to a file called 3 instead of doing the high-level optimizations. Ah, crap. Of course, the high-level optimizations are like, oh no, that's dead code, isn't it? How about O2? Do you give us anything better? O2 gives us, drum roll, we still optimized it out. Okay, so instead of that, we will come in here, printf, %x, NA. Right, so hopefully this is not able to optimize that out. But who knows? Maybe they're going to be able to say, oh, this while loop will never return. Like, you'll never break out of this. So, we cannot. So I want to go int q while q and q is equal to 1. Okay. So that you can't optimize. Well, q is equal to 0. There we go. Like, my compiler should not be able to say that can never get changed. I will be a little, like, impressed if it is. There we go. So we add all that up. We go in this loop, but we just jump? What? Okay. I guess my hope of optimization here means that we have to actually a plus equals a shifted by 8 and with oxff. Right, so that should be able to say you want the 8-bit register for it. And because of how we've set things up, we shouldn't be able to compile it out because it's dead code. Okay. Am I just terrible at math? If we add that every time, you need to be able to print it out. So, what? So you think you are always going to be 1? What? Is my math just that bad? Sure. So arm a.out, compile it again. Let's reopen this thing. What? No, seriously, how on earth are you able to make that assumption? Like, no joke. We're going to go in a loop until that gets set to 0. And then we're only going to do it once? GCC, why are you crazy? Okay, you know what? We're going to do it this way. Int b. Okay, I'm not crazy. You need to actually run that the number of times that it's going to actually do a thing, right? Oh, I guess I could do this. So I changed it, I know you can't see that, I just changed it to printing out B instead of A. Why does it think that that can never be hit? Q is equal to 1. Okay. This, like... it's gonna work, right? Oh my god, I hate you so much. I hope you know that. Like, I actually really hate you right now, GCC. I hope you understand that. Okay. If we change our optimization flags a little bit, we're now doing O1. Yeah, you know what? That makes a lot of sense. We'll do that. Like that. Nice. I do like mixing undefined behaviors into my proof of concepts. So for those of you who aren't following that, when we hit an integer overflow, it will cause undefined behavior because integer overflows are not defined in the C standard. However, that still isn't quite doing what I want it to do. Because what I want it to do is I want that to give me a... because you were able to optimize that away. Thanks. So what if I come over here and I... like, we'll mess with this in 2 different places. right? Like this. This should be non-deterministic the number of times this thing happens. You should not be able to optimize this away. How do computers work? Like, seriously, how do computers work? Because there's no way that... Like, I actually straight up think it's wrong here. Okay. Sorry. I'm now doing this. We're now doing Q plus equals A. Like, hopefully Jafra is right and this just works, and you can see things crash. I hate you so much right now, GCC. I really do. I don't believe that this is true. Okay, so let's go back and look at this thing. Wait, you know what? Fine. You know what? Like, if that's what you want to do, that's what you want to do. So if I open this again, so we're now printing it out every time, right? So by doing this, you have to do this calculation. We touch EAX, we touch BX, we touch BH and BX. Go away. So we are now less than 64 instructions. We're going to overwrite this. Yes. That's interesting. Now we're not printing anything. Huh. Oh, sorry. You guys couldn't see that. So this is this thing. Let's save this. And so this is doing basically what I expect to see. Why am I never seeing... Why are you never printing that out? Seriously, why is this never getting printed out? What is GCC doing? Okay, I've got to be writing something wrong here, right? So oh. Again, this is, if you remember, I said, every time I look up how to do this, I always forget how to do it. It's because I'm waiting for thread 1 to finish before I join all these other threads, and thread 1 will never finish. Okay. Yep. Yep. That is me being bad at computers. Much better. So that is printing out occasionally 32, which seems fine. And if we come in here, we reload this. And we, in thread 1, we patch out this call. Sorry. We patch out this call to printf check. Patch. Convert to NOP. File. Save. Overwrite this. Yes. What I expect to see here, what I'd really like to see here, is for this to go and crash. And crash. So let's take a look at this again, right? So we definitely are calling, so we're using BH here, and we're using BX here. Like, we're using both of them. If we go back to what this says, short loops of less than 64 instructions that use BH as well as their corresponding wider register use. So is it because I'm not reading from it too? This can only happen when both logical processors on the same physical processor are active. We have that. Oh, sorry. I should prove this over again, shouldn't I? So we have both of them active. So I would expect to see this doing something. Like, if we were going to see it do anything, I would expect to see it do something now. But we're not. We know hyperthreading is enabled. What else did we, where were we here? This one. So let's run this thing. So this is the test to see if we care. This may be a, oh, I'm a moron and don't actually have, yeah, okay, I do have hyperthreading. I have hyperthreading. I have a Skylake processor. If your processor model is 78 or 94 and the stepping is 3. Oh. Do I actually have the wrong version? So my stepping is 3. I have a model 94. Intel dash Ubuntu Intel microcode. Sorry. I will let you all read with me as I try and figure out what is going on. Did Ubuntu check microcode version. Sure. How to verify if there is new microcode. So if I get, I'll try and do this real quick. So sudo at git install iucode-tool. Yes. Mod probe CPU ID and iucode-tool-ls/tp/micro. Okay. So this is my signature. And if I come back over here, oh, sorry, I will go back over here so people can follow along with me, or following along at home. I have that signature. Ugh. The fixed microcode for these two processor versions should report. Okay. iucode-tool. What does this thing do? You can load it. Okay. I just want to know what version I have. iucode-tool-l -v. All I want to see is what version I'm using. What if I do so? So there is an Intel microcode. apt cache info Intel-microcode. Or apt. How do I do that? Apt get info? I want apt get no, I don't. Apt cache show. Dash cache. Apt dash cache show Intel dash microcode. Okay. So if we come back over here, This says that the fix was available 2017 5.11. And in particular, the version 2017-0511. Yeah, I'm using a version from 2015 here. I don't have a new version. Is there another way? So I haven't installed the package. I know that. So if I installed the package, then maybe. This is unfortunate. It seems that we have poked at this for a while. I have the right system. As far as I can tell, I have the right updates installed. I should be vulnerable to this, and nothing's happening. So, unfortunately, I think at this point, I think what we're going to do is call it an evening. I hate to leave everybody a little disappointed because we didn't actually get anywhere useful. I was really hoping we'd be able to see a crash right now. Like, getting to a crash would be amazing. But at this point, it's been about an hour and a half. Not entirely sure where to go next. I need to go research microcode to see how to check to see what version is currently running. And poking through that probably isn't the most interesting thing. And outside of that, I still haven't had dinner, and I'm getting kind of hungry. So, like I said, sorry we didn't get any farther than this. If anyone else is looking at this and finds anything, please let me know. I don't want to run around in circles if I could avoid it. So if somebody else makes some progress, I'd love to see it. I think that's about everything. We'll be doing this again on Wednesday, and hopefully on Wednesday we're going to actually be able to trigger this thing, because as far as I can tell, we have a machine that is vulnerable. We have code that triggers the vulnerability according to Intel. We just don't get it anywhere. I guess the other thing to do here is I'm going to do a.patched. And I'm going to let this run, because if you remember, the OCaml bug report said sometimes it takes over half an hour of running to cause problems. So maybe we just didn't wait long enough. Like maybe it's a very rare race condition that needs to trigger. Maybe. Maybe. But in any case, thanks everybody for showing up. Hopefully you all find these as enjoyable to watch as I do to make them. I know I definitely enjoy doing them, and having not been able to do these for about 2 weeks now has been quite disappointing. I've definitely been looking forward to this one in particular ever since I found out about this microcode bug. But if anybody has any questions or comments, like usual, let me know. Twitter is probably the easiest way to get a hold of me, or on the YouTube comments. Other than that, I will see everybody on Wednesday, and hopefully we'll have good news on Wednesday that we're able to make this crash and do useful things and find out what exactly is undefined behavior, because undefined behavior, a processor doesn't just do random things. It does a thing that is not the behavior that was defined. So hopefully that undefined behavior is something awesome. I would kind of love to find out that the undefined behavior is it just does the same thing on the same registers in both threads. But we'll see. So, in any case, thanks again everybody for showing up, and I will see you all in a few days. Bye.